Hi, everyone. I sure hope that you all can hear me. My name is Márton Braun. I'm an Android developer for Stream and a GD for Kotlin and Android. And today I'm here to talk to you about API visibility in Kotlin. And I'm talking about this topic because it's something that I use a lot in my day-to-day work because I do work on an open source SDK. We build a great chat product, so please do check that out if you need a chat integration in your apps. And I also use this in open source projects that I work on. So it's really something that I've been using a lot lately. So I decided to talk a bit about it. Now, let's start with a bit of like theory and intro. Let's define what an API surface is. So let's say that you're developing a library, but everything that I show here today will also apply to any module in a multi-module project. So you don't have to be a library developer. You can also be a developer for an end user app. If you have multiple modules, all of this should be really useful to you still. So the surface of your API, you're going to have a module first. And within that module, you're going to have a bunch of classes. And within those classes, you're going to have members, so properties, methods, and things like that. And for each of these things that you have in your library, you can decide whether or not you want to expose them to the external world. So you can decide that you want this and this class to be visible from the outside. And then for everything that's inside those classes, you also have to make similar decisions. So you can decide whether each of these members should or should not be visible to whoever's looking at your library. And everything that you push to the boundary of your module like this, everything that will be reachable from the outside is the API surface for your library. So with that out of the way, I'm going to now simplify this chart to this, where we still have the module and we have a bunch of declarations. We don't really care what these are: methods, functions, top-level things, classes, objects, whatever. But some of them are public, the orange ones, so those are exposed from the module. And then the green ones are kind of safe within the module. Those are not reachable from the outside. And of course, we would have these depend on each other in a bunch of ways. That's just how our code flows there. Then we would have another module, which would be our client. So this module contains some code that uses our library. And it, of course, references some of the things that are exposed from our library, something like this. Now, the next idea I want to get across to you is that having a minimal API for a module or a library is a very good idea. If we go to the good book, and I, of course, do mean effective Java, then we're going to find a recommendation about this. Item 15 says that you should minimize the accessibility of classes and members. And I'm not going to recite this item here. You should really go and read this item and the entire book yourself. But I just wanted to point out that this is some advice that has been around for a long while. It's in chapter 4 of effective Java, which is titled Classes and Interfaces. And it's actually the very first item in that chapter. So there's a lot of things in there, like minimizing mutability, using composition instead of inheritance, and so on. But still, this minimizing accessibility thing must be really important because it's the very first item within the chapter. Let's look at some reasons of why a minimal API is a good idea. First of all, it's a lot easier to maintain and change if your API is as small as possible. So anything that's not exposed from a module, you can freely change around. You can add new things. You can write new implementation, replace old things, remove things, and basically do whatever you want. But if you were to touch things in your module that are exposed to the outside world, then you would suddenly be breaking client code. So whoever your clients are will be quite unhappy about that. You're going to have support requests and all sorts of trouble. So that's not something you want to do like that. So what about things that seemingly are not used by clients? Again, this is something that you cannot be really sure about. So we have this declaration in our library, which we don't see any uses of. But we can only really be sure about this if this is just a module within the current app, and we have the entire project in our hands and we can check. Or if it's something like a company internal library and you can check every project that has been built on it. But otherwise, if you've made your library somewhat public and generally available, then there's always going to be somewhere out there who started using your exposed APIs as soon as you've published a version with them. So it's really hard to get rid of something that you put into a library and expose to your clients at any point. Kotlin does help a bit with this. And I'm going to show you an example that I've migrated recently. So I have a library called Crate, which is a Kotlin library for storing things in shared preferences using delegates. And there was this method in there which I wanted to remove. So I started the deprecation cycle on it. And Kotlin has a really awesome and powerful deprecated annotation for this, which is kind of like Java's, but it has a lot of superpowers on top of that. So first, you can specify a message which can guide your users as to what they should be doing, why this is deprecated, what they should use instead, and so on. And you can set a level to this deprecation, basically showcasing or indicating how serious this is. The lowest level of this is a warning. So at compile time, they're going to see some warnings in their compilation output telling them that they're using something that's deprecated. You can go further, though, with Kotlin's deprecated annotation. You can also specify a replace with option. Inside this replace with object, you can pass in a string. And this string will be used by the IDE to give your users quick fixes through intention actions. So in this case, I wanted them to replace the single method call with 2 parameters being passed into it with 2 chained method calls, with each parameter being passed into one of these calls. And as you can see, I can use things like the this reference as well as the names of the parameters inside the string. And then the IDE will suggest the replacement automatically for anyone who's using this deprecated API. And they can really quickly and easily migrate to the correct new APIs. If you're using some new constructs in there, in these replace with strings, you can also specify imports, which was actually the case for me. So that second function came from a new package that people would not have had imported yet. So I can also add imports so that those are also automatically added when someone replaces the old calls with the new ones. Then as you go along your deprecation cycle, you can have tougher and tougher levels of deprecation. So that was a warning. You can raise that to an error instead. So now anyone who has source code that refers to this method would have a broken build, and they would be forced to do the replacement. Still, they would have the intention action to do this quickly. So this shouldn't be too much trouble, but this is a way to actually force your users to migrate. And if you are really done with this method and you assume that all of your users have already migrated, you probably would remove it, or at least that would be your first idea about it. But you can also just mark it as hidden first, which will make it unresolved for anyone who's editing code. So there would be no chance that anyone is still referring to this in their source code. It looks like it was removed. But if your clients have already compiled code which refers to this method, then they're not going to face the runtime errors that would result from you having removed this method. But instead, as long as you keep that implementation around, just hidden, their already compiled code that refers to it will keep working, which is nice. I wrote a bunch about source and binary compatibility last year. So I encourage you to check this article out if you're interested in maintaining these things and a bit more about deprecations. Back to our minimal API topic, though. So why are minimal APIs a good idea? The second reason is that they are simply easier to learn. So if you start using a library and you see a lot of exposed things in it, let's say that it has dozens of classes and hundreds of methods, it's going to be really hard to figure out from yourself how to use that library. So you really have to go to the documentation and figure out what you're supposed to be doing, in what order, and so on. Whereas if a library has a small API surface with just a few entry points, and then you can go off of those entry points further and further into the library, then it's going to be easier to integrate because you can kind of just discover it on your own, even just through the IDE's auto-completion features. The other side of this same coin is that a library with a minimal API is harder to misuse because if you expose a lot of things from a library, then people are going to start calling every bit of API that you've exposed, even things that you didn't mean for them to be calling because maybe they're lower level implementation details. and you had a lot more convenient APIs provided. If you don't control what people are calling in your library, then they're going to call everything. That's just bound to happen. So how do you get to this really nice place where all of your API is perfectly figured out? Well, if you can afford it and you're starting something new, it's a good idea to invest a bit of time into planning. So when you start a new module or new library or anything like this, it's a very good idea to first just plan the exposed parts of your module. So plan the surface level API of it and figure out what client code that calls into your APIs is going to look like. And once you've done that, and once you've designed that and considered different use cases, then should you go and actually implement the like details of the library and then write the actual implementation code. And you can, of course, always just change the implementation later. The really hard part is getting the API right, because that's something that's extremely hard to change later on. With that, though, let's bring all of this back to Kotlin and talk about visibility in Kotlin. As you might know, everything in Kotlin is public by default. If you don't put a visibility modifier on something, that thing is going to be public. On the other end of the spectrum, we have private, which restricts accessing things to the current file or the current class, whatever scope you're in. And we also have a visibility somewhere in the middle, which is internal. Anything that you declare as internal will be visible in your current module. So if you're a library, then only within your library. But outside of that, clients and other modules will not be able to reference it. This is a visibility that you should use a lot if you're working with modules, because there are a lot of use cases where this is the appropriate and convenient visibility. For example, there's the classic case when you want to have an interface exposed to your clients, and then the implementation of it should be private to your library. Here, the interface can be public, and then the class that implements it can be marked as internal. If this class was private, then you could only create instances of it within the same file, which would be tedious. But by making it internal, you can refer to it within your library, but no one outside of it will be able to see it. You can also split a single class into public and internal parts, and even a single property. Here we have a class which is exposed to the outside world. This network client is a public class, and it has this property called state in it, which we want clients to be able to check to see if we are connected or not. But we don't want them to be able to change it. So in this case, we can use a mutable var property. But we can mark its setter as internal by just adding the words internal set after the property. And this way, we can only modify it within our current module. Of course, in this specific example, we might want to restrict this even further and make the setter private entirely. But sometimes you do need access within your own module. Also, note that by making the setter private or internal, anyone who's looking at the client from outside of the current module will basically see it as a read-only val. Another thing that you should really use internal visibility for is extensions on common types. So if you have utility methods inside your library that extend string or int or any common type like this, you should really consider marking that internal, because otherwise that's going to show up in everyone's code bases all over the place when they include your library. And they will probably start relying on it even in places where you don't expect. And then when you change this in your own library, you might again be breaking client code. The same applies to non-extensions as well. So just regular top-level utility functions. Let's say you're an image loader library and you have to do something with graphics, and you have this average of function inside your code base. This is probably not something that you want to provide as API as an image loader. It's just not the kind of thing that your library is supposed to do. So you should make sure that you mark things like this internal, because otherwise, again, people are going to start using this and using it for completely unrelated things that have nothing to do with your library otherwise. Testing needs to be mentioned when we talk about internal visibility. If you have some private state in your production code and you want to write tests for it where you make assertions on that state, then you're going to have problems because test code cannot access things that are private to a class or a file. But internal is really handy here because the test source set is allowed to access things that are internal in your production code. So this is a good way of exposing something for tests, but not exposing it to your clients. If you're on Android, you can even make this more explicit by adding the visible for testing annotation, which indicates that this value would otherwise be marked private. This property will be private, if not for having to access it for tests. Then let's talk a bit about the Java interop of how internal works. As you might have noticed, Kotlin is a really great type-safe language, but when we start interacting with Java, we eventually see that that type safety breaks down a bit, and we can come into dangerous situations. For example, with nullability, it's pretty easy to produce null pointer exceptions if you're interoping between Kotlin and Java code. So the same applies to internal visibility, unfortunately. So if you have a declaration in Kotlin that's internal, so I have this method here inside my class called createEntity, and it's marked as internal, then you can still write Java code in another module that will access this method because Java and the Java bytecode doesn't have a notion of internal. That's a Kotlin-specific visibility. So Kotlin internal declarations are actually public at the bytecode level, which means that if we're writing Java code, we can do something like this. We can create an instance of this repository, and we can call the method even though it's internal and in another module. As you can see here, the name of the method is mangled when it's marked as internal, but it still remains accessible. What can we do about this? Well, we can stop this mangling, which might be useful in some cases. So I wanted to point it out by adding the JVM name annotation. So this controls what the name of the method will be when it's compiled down to bytecode. And we can use this to either make the API nicer for Java clients so that this mangling doesn't happen. Or as you can see on this slide, we can attempt to use this to scare Java clients away by making the name of the method something scary. But really, the ultimate solution, if you want to prevent Java clients from calling into this method, is to mark it with JVM synthetic. Anything that's synthetic, marked as synthetic in the bytecode, which will be done if you add this annotation, will be inaccessible from Java source code. So this applies to both external modules and your own. So if you have a mixed code base and you want to access this from Java code, then you're basically out of luck. But you probably are writing a lot of Kotlin code and hopefully very little Java code. And in those cases, JVM synthetic can be super useful because it hides a declaration from Java clients entirely. OK, so we've covered internal visibility. And I've mentioned that having a minimal API is a very good idea because it's just going to make your life easier as a library maintainer. But it's still very easy to forget to check that a certain method or a certain class has the appropriate visibility. It's easy to create something and leave it as the default public. This is what Explicit API mode in Kotlin is supposed to solve. It's a new language feature from Kotlin 1.4, and it enforces two rules. One of them is that you're going to have to add explicit visibility modifiers for all of your declarations. So you're going to have to make the decision about whether it should be public, internal, or whatever else. And you're also going to have to add explicit types for all of your public declarations. We're going to look at both of these rules, but first, let's take a look at how you can enable Explicit API mode. The easiest way is to add this to your Gradle configuration. So call the Explicit API method inside the Kotlin block. The other way to configure this is through Kotlin's compiler options, which is a lot more verbose, as you can see here. But this might be useful still. As you can see, the thing that actually enables explicit mode is just the code in the middle, which is the Explicit API flag being set to strict. So even though this is more verbose, you might want to still use this approach, because as your project is evolving, you might find yourself adding more and more options to this list. So for example, this is also the place where you could enable progressive mode, which makes you opt into some new Kotlin features faster within your project, so you can always keep up to date with the latest language changes. Both of these configurations do the same thing as far as Explicit API mode goes. And if you enable Explicit API mode like this for a module, then everything that doesn't comply with the rules will be marked as an error. So you're going to break every declaration that doesn't comply with this, and you're going to have to migrate your entire module at the same time. Now, if you're in a project that has a lot of modules, then this is still viable option because you can go module by module and enable this strict mode for each of them and migrate them one by one. But if you have just one very large module or some very large ones, then you might not want to mark everything as an error immediately. In that case, you can use the more relaxed warning level for explicit API mode, although I do recommend that you try to go for the other one. So let's take a bit of code and see what happens when we enable explicit API mode. Well, what happens is that it's going to light up like a Christmas tree, which is appropriate for the season, but is not something you like seeing in your IDE. So the problem here is that all of our visibility in this class is completely implicit. So we would have to mark our class as explicitly public, and we would have to do the same with our properties. And then we could review each of our methods to see what we would want to have as a visibility there. For example, this say hi method looks fine, so we can make that public. But then if we take a look at this reset function, then this looks like some sort of like leftover debug code, which we might want to remove or at the very least mark as internal. So this is the kind of review process that you would have to do for everything in your module when you enable explicit API mode. Make a decision about each declaration and see what its correct visibility should be. As for the other part of explicit API mode, which is that everything that we've decided should be public has to have an explicit type, let's see why that's a good idea. We have an interface here with a method in it called client, and it has a default implementation where it returns the value of this default client property. We don't have an explicit return type for client, so this would be an error when we enable explicit API mode. But why is this useful? Well, right now the return type of the client method is being inferred from the type of the property, which in turn is being inferred from the assignment's right-hand side, so the constructor call of client. So if we make some change like this, if we decide that the offline client implementation would be a better default option, then we are suddenly and implicitly, this is rather hard to spot, changing the public API. So for example, if someone has already implemented the client factory interface, their code is likely now broken because they only had to return a client before, whereas we now change that to an offline client. So these are the situations that explicit typing on public API can avoid. And you can solve this by complying with explicit API mode and just stating all of your return types like this. OK, that's all for explicit API mode. Let's now go to another scenario that you might come into when you're dealing with visibility in a module, which is something like this. So we have two functions here. One of them is an inline function. That's the public API that's called song. And then we have an implementation function, which is marked as internal, which has the actual implementation code in it. And if you start writing some client code in another module, then what you would, of course, call is the public-facing function, so song. The problem with this code is, well, that it doesn't compile. You're going to have an error on this line, which says that a public API inline function cannot access non-public API. So for some reason, we're not allowed to call secret function inside song. And this is something that's related to inlining, as we can see from the error message. So the reason why this happens is because of how inlining works. So whenever you mark something as inline, there won't be a real method call or function call happening at runtime. So there won't be a call to song when we run our client-side code. Instead, what happens is that at compile time, any calls to the song function will be replaced by the contents of the function. In this case, that would just be a call to secret function. But if this happened at compile time, then our client's compiled output would have references to a function that's internal inside our module. So we expect that there are no external references to this, and we expect to be able to change this freely because we've marked it as internal. But if we allowed this to be inlined into client code, then this expectation would break. So the compiler doesn't allow this. Now, one solution would be to just make our previous function non-inline, which you can get away in some cases and you can't get away with in some others. So if you need non-local returns, if you have a refight function, you cannot make it non-inline. So in those cases, if you want to decide to instead expose your internal function, you can use the published API annotation. By marking this function as published API, it will be available inside inline functions, even though it's internal. And it really will be inlined into your client's bytecode. So anything that's marked with published API, you have to treat it very similarly to public API. Because if you make changes to it, you might break client code. Although you can only break already compiled client code, which is less serious problem than client source code, but is still a problem. And of course, we've still kept our function as internal, so there cannot be any direct references to it in source code. Your clients are still only going to be able to call the song function. Again, if you want an intro and some things about source and binary compatibility, especially when it comes to Android, you should check out this article after the talk. And with that, we're going to get to our last visibility-related topic for the day, which is opt-in APIs. You probably already encountered opt-in APIs if you're using Kotlin a lot. If you're using some experimental coroutine APIs or maybe the new experimental time APIs, then you have already seen that you had to add some kind of annotations to enable these because they were otherwise producing warnings. The use case that I want to present here is that we already have this library that we've created earlier, and we have some client code calling it. Let's say that we want to add some new functionality and ship it to our clients, but we don't want to add it to this library because it's something that not all of our clients are going to need. We want to make it optional. So we decide that this is going to be our core module, and we're going to create a new add-on module that builds on top of that. Now, our clients would be able to include both of these libraries in their projects and use the exposed public-facing API of both libraries. And in the implementation of our add-on module, our add-on library, we could also use the things that are in our core module, and we would be treated as another client. So we could only reference things that are exposed from the core module in our implementation of the add-on module. But what if we wanted to break that? What if we needed something from inside the core module, which is not something that we want exposed to clients, but we need in the implementation of our own second library? Well, you can use opt-in APIs for this as well. And the way to use them is to create your own annotation that's going to mark any things in the library that require opting into. So the usual pattern for this is something like internal name of the library API, like internal coroutines API, and so on. So I'm going to call this internal my library API for now. And you have to annotate this with a requires opt-in annotation, which is very similar to the deprecated annotation we've seen earlier. So you can specify a level here, which can be error or warning. In this case, we are probably going to keep it as an error because we want to be quite strict about this. There are really two good use cases for this. One of them is to ship experimental things that might change to your clients. In that case, warning is probably enough so that it's easier to opt into. But here I'm using it to just share things within my own modules, and I really don't want clients to start building on this, so I'm going to go with the stricter restriction. And then we can also add a message where you can describe that this is some internal API or experimental API, and just like set some expectations to your clients so that they know what they're opting into if they decide to start using it. To use requires opt-in, you have to opt into using requires opt-in. So the entire opt-in system itself is still experimental, so you have to opt into it, which again you can do by adding some Kotlin compiler options. If you already have explicit mode enabled, you already have this whole block. You just have to add a new line to it. So this is how you would opt into using the opt-in system. And then from here, you could start writing code in that core library where you make that public so that it can be accessed from outside of the module, but you mark it with this annotation so that it will produce an error when someone tries calling into it. So this is the big picture. We've set all of this up in the core module. Now let's see how we can call it from the add-on module. If we start calling it or try calling it just regularly, we're going to see that error that I mentioned previously. And we have two ways of making this go away. One of them is to further propagate the opt-in requirement. So if we mark this function with the same opt-in annotation, then we are free to use any other APIs that have the same opt-in requirement. And whoever calls this add-on function will have to opt into it somehow, or again, further propagate this. Now, this is not what I want in this use case. I want anything that's in the add-on module in public to be easily callable. So I want to somehow make this opt-in requirement go away, which I can, again, do in two ways. One of them is to opt into using these APIs for the entire add-on module, which is, again, a bit of Gradle configuration. You would have to add the opt-in compiler option and specify the fully qualified name of your annotation that you're using. From here, I could use these APIs that are marked with the annotation inside the entire add-on module freely. On the other hand, I can also opt into this locally if I don't want to do this for my entire module, which I can do by using the opt-in annotation and then passing in the annotation that I'm opting into as an argument. Since the opt-in system is experimental, you have to opt into using opt-in to be able to do this. So you're not avoiding the Gradle configuration in this case either. But this way, you can be more considerate about just how many places you want to allow using these internal APIs. And once you've done this, you can opt in at a statement level, like I've done previously here, or you can move this to a function or a class or an entire file. But if you end up opting into these APIs in a lot of different files or a lot of different classes, you might as well just go with the previous approach and opt in for your entire module. Of course, I still have to mention Java clients again. So if we make a function in the core module, like this core API function up top public, then any Java clients will be able to easily call it because Java, of course, does not respect the opt-in requirements. So if you want to prevent Java clients from doing that, you probably already know what to do. You can mark these things as JVM synthetic so that nobody who's writing Java code can access it. And that's basically a wrap for this talk. So I want to point you to some resources. First, there's this very same talk available in written form that you can check out if you need some of this Gradle configuration and things like that. Then there's the talk about maintaining compatibility that I mentioned a couple of times that I also want to encourage you to read. And then there are the two effective books. I've mentioned Effective Java at the beginning, and then my example for explicit typing with explicit API mode was stolen from Effective Kotlin. So you should probably also read that book for some best practices. If you're looking for the slides or these resources, you can go to my website's talks page where I have all of this gathered. So that's the easiest way to find all of this. And if you're into Twitter and that sort of thing, you can also follow me there. I tweet hopefully useful things about Kotlin and recently a lot of complaints about Android Studio because it's really broken for me. To sum things up, minimal APIs are a very good idea for any module. Internal visibility is super useful in Kotlin. Explicit API mode is one of your best friends if you're a library developer and don't want to accidentally expose things. Published API can be useful if you're dealing with some inlining problems. And opt-in APIs are great for either shipping experimental things to your customers or restricting things to kind of a library group. Thank you for attending this talk today. I'm going to go to the Q&A. So if you have any questions, please put them into the chat. I think I'm not seeing any questions yet. I wonder how long we should wait around for that. Of course, you can always find me on Twitter or the Kotlin Lang Slack afterwards if you want to ask anything. When maintaining a library, which is the most effective testing method to ensure that you're not breaking any public APIs? There are tools for this, and I don't know all of their names off the top of my head. There are tools that let you check what the API surface of your library looks like, and you can make diffs to see if you've changed anything, like accidentally removed a method or added a parameter where you shouldn't have. I'm going to eventually add those to the references of the talk, but if you contact me somewhere, I'm also going to send you some links for that. I just have to look them up. anything else? Okay, I think that's it. Thank you again, and stay tuned for the other talks. Bye.